Hello everyone, welcome back to my YouTube channel. I am Lochana MR, studying in Sri Venkateswara College of Engineering, Bangalore. I am from the Department of Information Science and Engineering. Today in this video, I am going to discuss about the subject Data Structure and Analysis, DSA. The subject code is BCS 304. In data structure and analysis, today in this video, I am going to discuss about the topic dynamic hashing with leftist trees. So first, let me see briefly about the topic dynamic hashing and leftist tree. First, we'll discuss about the introduction to dynamic hashing. Dynamic hashing is a method used to manage hash tables dynamically. It allows for efficient insertion, deletion, and searching of keys. The primary goal is to reduce collision and maintain performance. Next topic is understanding hashing. Hashing transforms input data into fixed size string of characters. A hash function map keys to indices in a hash table. It is crucial for quick data retrieval and storage. So now let me see what is the limitations of static hashing. Static hashing can lead to the performance degradation with varying data sizes. It suffers from the problem of fixed size tables, which can overflow. Collision and static hashing can lead to increased lookup times. Static hashing is a type of dynamic hashing. So now let us see briefly about dynamic hashing. Now we'll see what is dynamic hashing. Dynamic hashing addresses the limitations of static hashing. It allows hash tables to grow and shrink as needed. This adaptability keeps operation efficient even with fluctuating data sizes. So now in this slide, let us see about the another part of the topic, that is leftist tree. First we'll see about the introduction to leftist tree. A leftist tree is a type of a binary tree used in priority queues. It maintains a specific structure that allows for efficient merging. The leftist property ensures that the shortest path of the null node is always on the left. So now let us see, why do we use leftist tree? What are the uses and the purpose of leftist tree? Leftist tree are efficient for operations like merging and deletion. They provide a way to maintain balance dynamically. Their structure supports dynamic memory allocation efficiently. Now in this, we will combine the part of the topic, that is combining dynamic hashing and leftist tree. The combination enhances both collision resolution and dynamic resizes. Leftist tree can maintain bucket lists in dynamic hashing. This allows for efficient handling of collision through tree operations. Let us see what are the operations in dynamic hashing. Insertion, deletion, and lookup are the fundamental operations. The table can expand or shrink based on the number of elements. Each operation is designed to maintain balance in the structure. Now let us see about insertion and dynamic hashing. New keys are hashed to find their appropriate bucket. If a bucket exceeds a certain threshold, it triggers a split. Leftist tree can be used to manage the overflow efficiently. The operation of dynamic caching is deletion. So let us see deletion in dynamic caching. Deleted keys are removed from their respective buckets. If a bucket becomes too empty, it may trigger a merge. Leftist tree help manage the remaining keys efficiently. Now let us see about the lookup operations. Keys are asked to locate their respective buckets. Searching within the bucket is optimized using leftist tree. This results in faster retrieval times even with many collisions. See the performance analysis. Dynamic hashing with leftist tree provides average case constant time for operations. The amortized complexity of insertion and deletions remains low. This combination reduces the likelihood of collision effectively. Space complexity. The space complexity of dynamic hashing is generally O power n. Leftist tree can help keep memory usage efficiently. This allows for the expansion without significant overhead. Let us see the comparison between static hashing versus dynamic hashing. Comparison with other hashing techniques. Compared to static hashing, dynamic hashing is more flexible. Other methods like open addressing can be less efficient in high load scenarios. Dynamic hashing with leftist tree offers a balance between speed and space. Let us see some of the real world applications of dynamic hashing and leftist tree. Used in databases for efficient record retrieval and management. Implemented in memory management system for dynamic allocation. Beneficial in caching mechanisms where quick access is essential. Some of the challenges and considerations of dynamic hashing and leftist tree. The complexity of implementing dynamic hashing can be a challenge. Ensuring balanced leftist tree requires careful management. Performance can degrade if the hash function is not well designed. Now let us see some of the future direction of dynamic hashing and leftist tree. Research is ongoing into optimizing hash function further. Combining other data structures can enhance performance. The exploration of adaptive strategies for varying work overload is promising. So now let us see about the summary of key points of dynamic hashing and leftist tree. Dynamic hashing with leftist tree provides a robust solution for hash table management. The combination allows for dynamic resizing and efficient collision resolution. Understanding and implementing this concept can greatly improve data handling. Now let us see about the last conclusion of dynamic hashing and leftist tree. Dynamic hashing with leftist tree is an advanced technique in data structures. Hashing is a useful tool to verify files are copied correctly between two resources. It can also be used to check if files are identically without opening and comparing them. A tree is recursive in nature as it is a recursive data structure. It is so because each tree contains multiple subtree as each node in a tree is a root node to another tree that makes it a subtree. It bridges the gap between efficiency and adaptability in ash tables. Mastery of this topic can greatly enhance the algorithm design skills. Thank you for watching my video.